Okay, so welcome back. Now we're going to do a couple of examples. So the first example that we're going to do is this alternating series. We have this series, which is an alternating series, and we have -1 to the n plus 1 power divided by n squared. Okay, so all we have to do is show that those two conditions are satisfied. Okay, so first of all, let's look at the term. Right? So what's the terms? We can show, again, that the terms are decreasing. Okay? Well, if we do this, let's do 1 over, -1, let's do -1 to the n plus 1. So this will be -1 to the n plus 2. Let's do n plus 2. And so this is going to be n plus 1 squared. So I'm just adding 1, right? And then what I'm going to do is I'm going to compare that to -1 to the n plus 1. Okay. Oh, sorry. Keep forgetting we're looking at the b sub n term. Here, let me show you. Okay, let me do this a little differently. Let's write this in the general form. So we can see it better. This is going to be -1 to the n plus 1 times 1 over n squared. Okay. So this, don't want to go too high, let me do it on the bottom here. So this is our b sub n. Okay. So we want to see that this is decreasing, right? And the limit goes to 0. So now, if we look at 1 over n plus 1 squared, and we look at n squared, 1 over n squared, now we can see that this is the next term, so this is one term, this is the next term. We can see obviously that this is less than that, and that's true for all n. Oops. Greater than or equal to 1. So we got that. And it's obvious that if we take the limit as n approaches infinity of 1 over n squared, that equals 0. So therefore, by the alternating series test, the series n equals 1 to infinity of negative 1 to the n plus 1 over n squared converges. And that's it. That's all you have to check. Have a great day.